So yeah, today we will be just talking about Otel, the good, the bad, and the ugly. So as the moderator has earlier said, my name is Manasseh and I'm at SRE at Zapier. And if you want to reach out to me, these are some of my social handles. I'll drop the slide. I think the moderator will share the slide after now. So you can send me a message on Twitter or I don't know, book a report that I contribute or that I'm working on GitHub. So yeah, let's start properly. So today we'll just be discussing Otel. These are like the outline of what this talk is going to be about. First things we'll start with understanding how observability has come so far. Then we'll understand why the need for Otel. Maybe we'll play around with a little demo, and then we talk about like when Otel is not the answer to some of your observability problems. And hopefully we'll talk about some best practices for Otel. So just for like an information, just FYI, this talk is not going to be talking about how to instrument applications. So what I mean here is I'm not going to be dissecting what metrics to collect. For example, I have a web server. What metrics do I collect for that web server? No, that is not what we are going to be discussing in this particular talk. What we want to discuss is open telemetry. That's what we want to discuss, how you can handle the instrumentation data. So I have collected my web server metrics. I've collected my web server logs. I've collected my web server traces. How do I process them? Where do I store them? Right. So the talk is going to float around these topics. And then we'll, as we progress, we will see like why the discussion is going to another direction as opposed to just talking about how to instrument your application. So from the very beginning, observability. So observability has had like different definitions like over the years. People have tried to define it in different ways. With every new year, I guess there's always a new definition for observability. But the one I find the most interesting or the most appealing to me personally is this definition by Hazel. Hazel, that's an SRE that has a blog that I follow. The link is in the reference section at the end of the slide. But she said observability is a process through which one develops the ability to ask meaningful questions, get useful answers, and act effectively on what you learn. So like there are three components there. First thing, the first part is you ask meaningful questions. Is my web server up? You get meaningful answer, no. And then you act effectively. Like how can I fix that that particular problem? So that means your observability is not complete without these three sections. If I cannot ask a question and get an answer, it's not complete. If I can ask a question but I don't get meaningful answer, it's also not complete. If I get an answer but I don't know what to do with that answer, then it's also not complete. So if you're instrumenting your application, you have to put these three things into considerations. So how do I get a question? How do I ask a question? How do I get an answer? How do I get like a possible solution to those problems that I'm giving you the answers? And observability has been around for like years, from the very beginning. From the very beginning. And right at the beginning of everything, there was availability. So availability is like one of the first or the earliest metrics for observability that was around. So the early systems, I think when John von Neumann, when the earlier creation of the early systems, people were not really interested in other metrics. Everybody just wanted to know, is the computer up or not? At that time, a computer was like a very, very big luxury. So only the very rich could afford it. So if you have a computer, you want to know if you can use a computer. So that was the major metrics at the very beginning, right? So you want to always know like if your system is up and running. And then as the eras kept moving forward, we moved from a computer being a luxury to computer being something that everyone can get. And then from there, we moved down to having the internet. So with the internet now, there are different websites, different services, and you could visit a particular website from your own system. And then it started evolving. The observability started evolving. All right. So people started asking, okay, is this website available at this particular time? If you are like the era of Java phones, which I don't know how many of us here use them, then if you wanted to like download a game, you want to go to like WebKit or WebTrip, whatever the website is, Stefan. By that time, you're not really interested in like the latency most times. What you're most interested in then is, can I download this particular game? Is the site available? Right. So those earlier systems, those earlier websites, their observability was just mainly availability. Just wanted to know if this is up or not. And this was implemented using network pings. So you ping the website, you send HTTP checks to confirm if there's like a valid response. If there isn't, you know that the website is down. If the response is valid, you know that your website is up. So this was like the earlier implementation of observability, or let me say availability, like in the early systems. I think this was around the 90s into the 2000s. So, but as we all know, like where we are standing today, the observability has evolved. That means people have tried their best to evolve the observability ecosystem. So when we had observability, when we had availability, system engineers had problems. So let's say web designers, if you would, they could not understand their systems better. Just knowing the uptime of the system was not enough. So I wanted to know more. For a system engineer, I want to know if let's say my database is functioning fine, if the connection between my DP and my app is fine. So like there was more need for in-depth observability, and that's led to systems monitoring. So systems monitoring here is the next era that came after just simple availability. So since then, systems monitoring here came with scripting. So you write a bash script, for example, and the bash script monitors, but the bash script runs, the bash script checks maybe some memory locations to confirm that the app is working fine. So basically, you can have like hundreds of scripts. Each of these scripts do different things and check different things. So when there is a problem with any of the scripts, you get a notification, or you get like an email that tells you, okay, this particular script failed, and this was why the script failed, and then you can like go ahead and see what the problem is. And for a long time, this was very fine. Like, for a long time, this particular solution was fine. People were okay with it. You know, like we just have a lot of scripts, and they just run each of these scripts at regular intervals, and then find out what is happening like in the system. And I think then the most popular tool for instrumenting such observability was Nagios. So Nagios was there to run the scripts and then nag you if there is like an error. So that was why the name was Nagios, because it was trying to nag you when there's an error. And as you know, like when you have hundreds of scripts, the nags can become too much, and people were like, okay, no, we need to move on from something like this. Okay, we are just talking about systems monitoring. The era of 2010 was like one of the best eras when it comes to observability, because 2010 brought with it real user monitoring and APM, that's application performance monitoring. So real user monitoring here is where we try to move observability from the system to the user's perspective. So I'm visiting the website. Instead of trying to measure the performance of the website alone, you also want to measure how the user himself experiences the system. So things like how long the page takes to load. Does the user face any error while it's loading the page? So all of this like came into play like during the 2010s, and this was very, very, very important for plenty of organizations, because now they can understand their users better. They can finally see what their users are seeing. Because it is one thing to be able to see what a system is doing, but it's another different thing to be able to see what the users perceive the system as doing. Right? So we had real user monitoring, and importantly, we had APMs. So APMs were like an added feature to like meant to logging and metrics. So logs give you, just normal logs like, okay, this has failed, this has passed. Metrics give you values that tells you how something is performing. But tracing now gives you a deeper dive into all your system code, all your function code in your application. So you can know which function took the longest time. You can know where the bottleneck of your system is coming from just by analyzing the traits. You can know, okay, this particular section of code is not efficient. We need to optimize this code. The APM also like give users or give the engineers like a whole lot of information with regard to the performance of their system. So yeah, like we just discussed like how observability came to this point. But one thing that this particular RUM and APM, not the user monitoring and APM, led to was the advent of several services or several platforms. So today we have Datadog. They offer you the same thing. They offer you real user monitoring and APM alongside log aggregation and like metrics. We have people using Prometheus. We have people using Splunk. We have people using like they are like you can count up to 100 services that offer you monitoring or observability. And you can see where the problem is coming from, because I can be working at this company, and in this company I'm using Datadog. Now I leave this company and I go to another company, and now I have to like learn how to write Splunk related code. So that became a problem, or this became a problem. It became a problem because too many systems, in each system had different ways of instrumenting code. So if I have a code that is if I have like a system and I've written the code to work with Datadog, and I say, okay, now I don't want to use Datadog anymore. I want to move from Datadog to Prometheus. I have to go back to that existing system and rewrite the entire code to use Prometheus. So you can see where the problem is coming from. Different systems, different method of implementation. And that was when people began to think, right? What if we could make telemetry data centralized? So what does it mean to make telemetry data centralized? All these platforms, basically, what they just need is the data. So Datadog needs the data, Prometheus needs the data, Datadog needs the data, Prometheus needs the data, Splunk needs the data. But one thing they don't really need is how that data is collected, right? So I just need to move the data from my application to Datadog. And if I can do that, it means I can still maintain the same code, but just change the backend to which this code or to which these metrics are being pushed to. So that was some questions that started arising. People started thinking, okay, how can we make it in such a way that I can write a code, but then how the data for that particular, how the metrics that the program collects is pushed to the backend, is independent of the backend itself. People started like thinking of possible solutions. What can we do? What if the telemetry data was collected once, processed, and sent for further analysis to the chosen backend, to the chosen tool? Or that's what I was saying earlier on. So we want to collect the data once, process it, and then send it to any backend we want. Collect it once, send it to Datadog, collect it once, send it to Prometheus, collect it once, send it to Loki, Elasticsearch. So the code doesn't change. The only thing that can change now is how you configure your backend. So you don't need to like always keep modifying your code. So that means if I was working with open telemetry, so if I was working with these two in this company and I go to another company, I don't need to learn another language or another framework of collecting metrics. I can just reuse the existing method and then just change the backend depending on what backend the company chooses to use. So yeah, we have Datadog, we have Neuralink, we have others. Like we have a lot of different monitoring services. So people's thoughts, what do we do about this, right? How do we make sure that we make life easier for all of us who are writing code for collecting metrics or collecting telemetry? And then that was when Otel came into play. So Otel was born out of the need for a decoupled, or out of the need for a centralized data collection mechanism. So one thing Otel does is it decouples the data collection and analysis from the data storage. So I can have my data collected using Otel and then choose how I want to store that data. If they want to store it in Datadog, I push it to Datadog. If they want to store it on Prometheus, push it to Prometheus. So whatever it is, no matter the backend, the method of collection doesn't change. Otel uses a single API, and it defines like some API specs. It unifies those API specs such that the code right here and the code right in another place, it's almost going to be the same thing. The reason that changes is how you define where to export your code, where to export your data, where to export your metrics and your telemetry. So yeah, just like Avatar, we have someone that can, control all the elements of all the elements of telemetry, all the elements of instrumentation. So yeah, that's like what we just did now was to run through the entire history of how monitoring our scheme has evolved over the years. So we came from just availability down to Otel. So now let's look at what Otel is exactly. Like, what are the components of these things that we call Otel? So what makes Otel special exactly? So Otel has like 3 key components. The first component here is the specification. So the specification here means set rules, conventions on how to do some things. So Otel has a convention of how to write an API. It has a convention of how to write an SDK, and it has a convention of how to collect your data. So that means if you are moving across software or across programs, these conventions must remain the same. So if I know these conventions, if I know these specifications, I don't need to stress myself with learning something else when I'm moving to another service, because I know that this is going to transform, or this is going to transfer from last program I wrote to this new program I'm writing. So that's like the first component of Otel, like this set rules, this all these defined rules and regulations around how to do things. And the second one here is the collector. So Otel comes with something called an Otel collector. So the Otel collector is like the magic that does all of Otel things. Or everything that Otel does most times is tied to this collector. So the collector is what is responsible for receiving the data, processing the data, and exporting it to your chosen backend. We're going to see in a bit like how this collector is implemented, and like how the components of these particular collectors as well. And then the last thing here, the last component of Otel is the language-specific API and SDKs. So Otel has different, if you depend on the language you're using, there is like an Otel implementation. If you're writing Python, if you're writing Go, if you're writing JavaScript, whatever it is you're using, Otel has a library for that. Otel has an SDK for that. So yeah, let's look at the collectors. So the first thing here is the receiver, the first component of the Otel collector, which is what is responsible for processing the data in the receiver. So the receiver is what is responsible for receiving the data from your code, right? So if I have like different code, I can define different receivers that define how that particular code is going to export metrics to Otel. So I can just open this link. So we can see this is Otel's library, and it has different receivers. So depending on where you want to collect your metrics from, Otel has like different ways to do that. The first one is you can use Otel's library itself. So Otel has like a library. So for example, if I want to start a new application, I can start a new application with Otel's library. But if I have already instrumented if I have an existing system already, let's say for example, I have an existing system that I've implemented with Prometheus library, I can use the Prometheus receiver here that tells Otel that, all right, I want to collect this data from a Prometheus service. And then Otel automatically knows it and then collects the metrics for you, and then processes it and then pushes it to whatever backend you want to. If you want to push it back to Prometheus, you can do that. If you want to push from Prometheus to Datadog, you can do that. If you want to push from Prometheus to New Relic, you can do that. So that's the first part, the receiver. The receiver determines, once you implement the receiver, what you're doing in essence is telling Otel how to collect the data. That's the first thing. Then the next one is the processor. The processors are basically what they sound like. They process the data. If you want to do that, if you want to configure any extra thing on your code, for example, on your metrics, before pushing them to an exporter, you can do them within the processor. So for example, let me give an example. If I'm collecting metrics from a service and I want to change the label for one of those tags in the metrics, for example, I want to change a job label and set it to like a service label, you can do that in the processor. So this is always dependent on how you want your data to be when you're pushing to the exporter. So you have a list of processors. You can write your own custom processor that determines how you want the data to be processed before it gets pushed to the exporter. And lastly, sorry, not lastly, second to the last, the exporter. The exporter here is what is responsible for taking that data and then pushing it to whatever backend you want. As we said earlier on, that Otel, one of the benefits of Otel is it allows you to push to different backends. So I can push from my code to Datadog, I can push from my code to Prometheus. So what is responsible for allowing me to do this is the exporter. So you have different exporters. And if I check this as well, if you check the Otel repository or the Otel collector repository, there's an exporter section here. So there are different exporters here. So if I want to push from my service to Alert Manager to AWS so you can see there are like lots of services here to Prometheus to Datadog, whatever it is your backend is, you can just define your exporter and then Otel handles, Otel collects the data, processes it, and then pushes it to that particular backend. So that's like one of the magic things, one of the magic that Otel does for you as a developer. The last component there is the connector, but rarely people use that. But basically, what the connector does there is it allows you to be able to take data from a particular receiver and pass it to another receiver. Kind of sounds confusing, but let's say, for example, I have a data that I want to pass from Prometheus to, let's say, to another Prometheus instance, or let's say from Prometheus here to another Prometheus instance, and then from this new Prometheus instance, I want to collect the data from the new Prometheus instance. So the connector here is what is going to help you connect the two Prometheus instances together, telling Otel, okay, that, all right, take the first data, pass it to the first Prometheus instance before collecting the data. So like the connector there is basically just to help you pipeline things together, like depending on how complex your data collection needs are, the connector there is there to help you. As I said, like rarely do people use connectors because most of the time, or most often than not, what our service just do is to push metrics, and we just want to collect the metrics and push them to our backend. That's like how most people want to set up their service most times. All right, so that's like a quick overview of like the major components of Otel, like what makes Otel tick. As we talked about, like the major thing there is the collector. Then we have like the APIs, the SDKs, and then the specifications. So what makes Otel good then? Like what are the good parts of Otel? As you can guess, like we've already discussed some of them already. The first one there is it gives you ownership of your own data, the data you generate. So if my application is generating metrics, I don't have to write the metric. I don't have to instrument my code in such a way that is locked to a single vendor. So let me give you an instance. Once upon a time, like within while we were at Zapier, we were experimenting new monitoring solutions, right? So at Zapier, internally at Zapier, we use Datadog and Prometheus for our metrics. But at the point, people wanted to like experiment with Honeycomb. So they wanted to like check out what they can do with Honeycomb because they said, okay, Honeycomb provides some extra features that Datadog doesn't. So part of the analysis or part of the review process for Honeycomb now is what would it take for us to use Honeycomb? And then you see that the acceptance criteria is we have to rewrite the code to remove the Datadog library and replace it with Honeycomb libraries. Right, so it means your code, when you write it at first, is boxed into the vendor you're using at that particular point. So if I'm using Datadog, I cannot switch from Datadog to another service because the code is dependent on Datadog, the Datadog library. And in this era of change, things are always happening, things are always changing. You want that flexibility as a company. You want to be able to say, my bill is too much for Datadog. I want to go for a cheaper solution, or I'm looking for a more robust solution, and I want to go for something else. And with the current setup that most organizations have, or with the current setup that most services have, you cannot easily do that. It is an extra, layer of engineering. Is that like how do they put it in product terms? It is extra engineering hours, right? Extra engineering hours for you to be able to take your code, refactor them, and then push them to a new vendor. But with Otel, you don't really have to worry about that. You write your code, and then Otel gives you the flexibility to choose where you want the metrics to be pushed. Then the second one there is you have to learn a single set of APIs and conventions. So this is almost tied to the first one, where we said you own your data. But the second point, they're just saying you don't have to learn all the libraries. You don't have to learn how to use all the libraries. There's a Datadog library, there's a Prometheus library, there's a Tempo library, there's a Honeycomb library, there's a Splunk library. Every vendor has a library. And if you want to learn how to use all these libraries, it's going to just be like very, very stressful for you. But with Otel, you just have to learn how to use one library. That is the Otel library. All right. So once you learn how to use the Otel library, or you learn how to configure Otel, then sorry, just a moment. Then once you learn how to use just the Otel library, you don't have to worry about learning something else because Otel handles the remaining backend for you. The third part is it's part of CNCF. That's a very, very good part because we know that CNCF, once a project gets into CNCF guarantees that the project like grows over time. They give them funding, they give them guidance, and they try to make sure that the project gets stable over time. So now that Otel is part of CNCF, we are somewhat guaranteed that this project is going to be here for a long time. So we can now start using this particular project. So the bad, what's the bad thing about Otel? All right. So the first one is the complexity. So as we have already earlier established, Otel has like 3 major components. But amidst the 3 major components, there's like the main one, which is the collector. And the collector itself has like other components under it. So you can see that sometimes, let me put this complexity as the initial hours it's going to take you to get familiar with Otel, right? So it might take you a while to like understand the Otel architecture, how to write the Otel code, and like wrap your head around how to use Otel. Once you do that, I don't think the first one there is actually a problem, but it is still a problem because most people, when trying to adopt a new framework, it takes some time for them to be able to adopt a new framework. The second one there is there's no full support for all the platforms and their features. As you can see here, like these are like a list of exporters. That's like possible backends you can have, right? But these are not all the backends because I'm pretty sure that all the monitoring solutions are more than this. So we can see that Otel doesn't have support for all the platforms that they have that are available. So depending on what platform you want to use, you might not be able to use Otel. You have to check and see if the platform you want to use is among the exporters here before you can use Otel. That's one of the bad things about Otel. And then lastly is the language support. So Otel has support for most of the languages. As you can see here, like the first one here, C++, traces, metrics, and logs, they are unstable. Otel has support for them. But as you go down, you begin to see that some of these other languages also don't have like full support for them. For example, if you use Erlang, you can only use, you're assured that tracing is stable, but metrics and logging is not stable. Right? If you use Go, tracing and metrics is stable, but logs is still in development. That means you can't even use it at all. So yeah, that's one of the problems. Well, that's one of the bad things about Otel. You don't have like full support for all the languages. And there are even languages that are not even here entirely. Like all those new languages, like I don't know, like, but most of those, we know that there are more than, I think this is 15 lists. There are more than 15 programming languages. And Otel has support only these few. It means if you're using anything outside this, you're on your own, you can't use Otel. You have to like go with whatever library the platform provides you with. So that's like one of the bad things about Otel. These are like the major bad things about Otel, like the fact that it doesn't have full support for all the platforms, and the fact that it doesn't have support for full support for all the languages. And even among the platforms it has support for, that's another interesting thing, it doesn't have support for all the features that the platform provides. So I don't know if this has changed, but as at the last time I wanted to use, or we were experimenting with Otel, we had an issue with Datadog tracing. So the way Otel exported the Datadog traces was not the same way the Datadog library exported its own traces. So tracing from Otel didn't have some of the inbuilt Datadog functionalities that tracing with the Datadog library provided. So that's another thing that is bad about Otel. Well, as I said, like it's under CNCF, so people are always working on this and making sure that whatever Otel has is almost identical to what the native platform libraries always have. The ugly part, adoption and challenges with the existing platform. The first, why I put this adoption and challenges there is I'm always going to reference Datadog in this code because that's what I've used mostly, especially with Otel. And at the earlier time when Otel first came out and released their Datadog library, there was an issue between Datadog and the Otel community. So what happened was Datadog charges you per host, right? So that means if I have like 10 systems, Datadog would charge me per system. So that means they will charge me, that's like 10 systems. They will charge me like 10 times whatever the cost of one system is. But with Otel now, as you can already guess, Otel uses a single connector. That means all the metrics come to one system, and then the system now exports it to the backend, which automatically breaks Datadog's pricing model. And when Datadog realized that this was happening, they implemented a pricing model specifically for people using Otel, and that was very aggressive, right? So it led to a lot of back and forth. And I think right now it has resolved because I think they have revisited those models, but I'm not fully sure. I'm not fully sure like around the details around that. But yeah, that is part of the problem. That's like one of the ugly things around Otel because some platforms realize that Otel is not giving them the money that they were getting before. So they are trying to like be aggressive with it and trying to make people move away from Otel, right? That's one of the problems there. And then the second one is the maturity. The question mark there because yes, Otel is not fully matured, but come on, like it's under CNC, right? So you can only get better from here. So it's a problem because I'm pretty sure that, for example, if you're using a new language, all of those experimental languages, you might not have problems. You might not have help from the community. If you're using some of those already stable frameworks, you will have help, but all those new ones, you likely not have help. But yeah, that's one of the ugly parts that you might face when you want to use Otel. So yeah, that is basically the main part. That's basically me discussing why we need Otel and how Otel has come to this particular point, or how people have decided to sit down come up with Otel. So let's just look at what this looks like in production or like in an actual service. I just pray that the demo goes on for me today. Uh,
Could you please zoom in, Manasseh?
oh, okay. Sure. You know what? I'm going to close this. Open another terminal. Yeah. So the code I'm using right now is available on the GitHub page here that we can see from my repo here. And the code it was forked from the original Otel library, but I made some few modifications to it to add some extra backends, some extra exports. So one of the advantages of using this code provided is it has a lot of services. This is a microservice. This microservice has different languages. Like I think accounting here is written in Go. Ad service here is written in Java. Cards here, I don't even know what language this is. But yeah, like you can see the point, like it has different languages, and the main point is to show you that you can instrument Otel in different languages, and each of these like have like their Otel implementation. I'm just going to open like one of the good libraries. Sorry, I don't write JavaScript, not anymore. Okay, Python, that's a good generator, that's a key. No, keep it go. So I'm not going to explain this code, but I just want to talk about like how Otel has replaced normal instrumentation. So before now, if you open a code like this, what you mostly be seeing here is platform specific libraries. So you will see something like Datadog library or Prometheus library. Right now, what you can notice is it's using Otel libraries. That means whatever we are collecting from this code is not tied to any particular what's the word, platform. Yeah. So yeah, we're not going to dissect the code because, as I said earlier, this is not a talk about like how to write instruments and how to like instrument your code, but just around how to collect the data that you are exporting from your code. So yeah, I'm going to go to the Otel configuration, which is one of the most important things here. So yeah, sweet. So we can see that once we open the Otel configuration, we have 4 sections. We have the receivers, we have the exporters, we have the processors, and we have the connectors. Then we have this last part called the service, but it's not a part, it's just a pipeline that determines how you are connecting your application or how you're connecting the data that Otel has collected so far. Let's just talk about them one by one. The receiver section here, I can see we have 3 different receivers. Right. The first receiver here is OTLP. So OTLP is when your data is coming from a code that has Otel. So like as I just showed us right now, the Go library, the Go service was using Otel specific libraries to instrument. So if the code you're writing, if the service you want to collect metrics from uses Otel specific libraries, you use an OTLP receiver. If the service uses like a Prometheus library, you can configure a Prometheus receiver. There are different receivers. There are different receivers and their configurations. But this one just has OTLP, Redis, and HTTP check. So that means it's going to collect data from OTLP, from any Redis endpoint that we specify, and then HTTP check means it's just going to keep sending things to check that the service is up. Yeah, that's like the receiver section. Then the exporter now is the interesting part. The exporter now, we can see we have different exporters. Exporters here, in exporter here, as we said the last time, we define where we want the data to be pushed to. The first thing here we can see we are pushing to Tempo. Tempo is a tracing backend for Grafana. So if you're using Grafana, you can use Grafana Tempo to collect traces. At the same time, I'm pushing that same tracing to Jaeger. So Jaeger is another different tracing platform that allows you to collect traces from your application. All right. Then we are pushing the metrics from this system to Prometheus. So if I have like an extra, metrics backend, I can push the data to that backend, where I can choose not to use Prometheus and push it to that particular backend. Then for the logs, we are collecting logs and pushing the logs to OpenSearch, which was formerly Elasticsearch. We're pushing the logs to OpenSearch, and also we are pushing that logs again to Loki. So Loki is Grafana's logging solution. So as you can see, like we are using the same data, but we are pushing them to different buckets, right? So what we want to demonstrate here is the power of Otel, like the fact that I can have one data but choose where to push my data to, right? And then the processors here, as I said, the processor is just to determine how the data is going to be processed once they're collected. But most times you don't really need to configure this. You can just set it to batch. So batch just basically does like the basic Otel processing for you, and then move the data for export. Connectors, these connectors, as I said last time, you can fit them on empty because I'm not doing anything serious here. So I don't think that's doing anything. Then the most important part here is the pipeline section. It determines how you collect instrumentations, depending on the type of instrumentation you're collecting. So if for traces, for example, for traces here, I'm saying, okay, for traces, I want to collect tracing from OTLP and process it within, I want to collect traces from OTLP endpoints. Batch is process it using the batch and then export it to Jaeger, Tempo, to debug, and to span metrics. The span metrics, you cannot forget it because, as I said the last time, it's not really important. And then for metrics, it's the same thing for metrics. I want to collect metrics from this endpoint, HTTP front end, from Redis, from OTLP, and then push them to Prometheus, as I've defined it. Push them to Prometheus. So basically, this particular pipeline determines how Otel is going to move your data around. So if I can define everything at the top, but if I don't define them in the pipeline, Otel is going to ignore them. The pipeline is like where the magic happens. So for example, for logging here, we want to collect logs from OTLP and then push that log to OpenSearch to Loki and then to debug. Debug basically means you want to print them to you want to print it on terminal on the SSD out, basically. Yeah, we can also see how this is working in real life, if that was the thing. So pull this image is already. Okay. That's all right. So everything is up now. I'm just going to copy this URL, just Grafana's URL. I'm going to open it here. Oh my God. Sorry. This is the URL. I'm also going to open Jaeger. I think this is it. This is Jaeger. Yeah, I think these are the major backends. Yeah. So yeah, I have a dashboard here. I basically just let me not use the dashboard. Let me just explore here. So this is Loki. I'm going to query Loki for data. All right. So Loki is, as I said, Loki is Grafana's inbuilt login solution. I'm going to run query, and I can see that I have logs coming from the cart service in Loki. Right. And I can also query OpenSearch from here as well. So one thing that Grafana has done very well is it allows you to be able to create multiple backend, even without having to use the backend's UI. I can query the backend directly. So okay, there are logs here, but I can't view them. I need to probably just go back to the dashboard. Sorry, just a moment. So yeah, you can see this is OpenSearch. So I'm querying OpenSearch, and we can see these are logs coming into OpenSearch. But this is from the ad service. I think I should just key ad service. So it's going to be the same data. So as you can see, I'm querying the logs from Loki, from the ad service, and on OpenSearch as well. I'm querying the logs from the ad service as well. So from one service, I'm pushing to two different login backends. I'm pushing to Otel, so OpenSearch, and at the same time, I'm pushing to Loki. Right. That shows you the power of Otel. And if I come to tracing, this is Jaeger. I can check the trace for the ad service application. Jaeger shows me the trace for the trace for the ad service application. And I can also go back to Tempo. So Tempo is Grafana's inbuilt login solution. And I can also query for there's I can also query for the traces. These are some of the traces that are coming into Tempo, still from the same service, still from the same microservice. These have come from the front end service. We'll have to let me just go to, yeah, let me just use the front end service here. It's easier. Front end proxy here. You can see we are getting tracing from the front end proxy in Jaeger, and also getting tracing from the same front end service in Tempo. This is Tempo. So this is where Otel gives you that power. Collect once and run anywhere. It's like this Java had this concept: build one and run anywhere. That's what Otel is trying to do. Collect your data once and process them anywhere. You use any analytic tool of your choice to visualize your data, but just allow Otel to do the collecting for you, and then you can just choose wherever you want to store your data and visualize your data in. Yeah, that's like one of the powers of Otel. What have I not shown? I've shown logs, I've shown traces. Okay, yeah, metrics, obviously. Metrics has yeah. I can just open any of this. Yeah, sorry. So let me use Java instead. So yeah, these are metrics coming from Prometheus, right? So it is also allowing us to push metrics to Prometheus. So if I had like a different, if I want to push my metrics right now to Datadog, I don't need to go and rewrite my code. All I need to do is basically just come to Otel, add a new exporter here, because each exporter as in this particular repo, they have their configuration. So I'll just come to Datadog exporter here. So you can see how to configure Datadog exporter. Where is it? Datadog exporter. Batch. Okay, yeah. No, that's not it. Sorry, that's not it. Okay. Sorry, let me just open this. Where is Datadog exporter? Yeah, yeah. So I will just come here, I'll copy the Datadog exporter configuration. I add it to the list of exporters, for example, and I come to my pipeline and tell Otel that, all right, also push that same data to Datadog. And that is all. That is everything Otel needs. So Otel is going to take the same metrics and push them to Datadog. If I choose no longer want to use Prometheus, all I have to just do is remove Prometheus from the list of things that I'm exporting to. That is it. Otel handles everything. So in doing this, Otel handles everything, all the instrumentation for your code, and then gives you the ability to choose where to store it from. All right. So yeah, Otel the careers go well, no, for real, because it has been helping lives. It has been helping lives. That's helped my life. Most times I write my code now with Otel without having to worry about where I'm going to store the code. And then when I'm done, I can now start thinking, okay, where do I have to, like, what platform do I want to use? Do I want to use Prometheus? Do I want to use Grafana? Whatever platform I want to use, I can make that decision after I've been writing my code. That's thanks to the power of Otel. So if you're not using Otel today, you might want to consider using Otel. If you already have existing systems, you can use the Otel receivers to define how to collect metrics from those systems. If you're planning on using a new service, if you're planning on starting a new service, you can think of starting a new service with Otel. Yeah, and that is the end of this wonderful presentation or this wonderful session. So I need questions, but only the easy ones. Yeah. Yeah, John Paul.
Okay, so first of all, I want to thank you for the session. It was nice, and I learned a lot. So my question is, earlier you showed us some of the features that are experimental. So my question is, do you use those functionality in production? That's the first question that I have. The second question is personal to me because I have requirements to implement both Istio and Open Telemetry at work. I want to know if you have experience of, because Istio also provides some level of observability. So I want to know what I have experience of combining both.
All right.
Basically,
So
your
to answer
opinion.
yeah. I'm going to try and give you my best professional opinion. To answer your first question, with regards to experimental features, people use experimental features in production almost most of the time, especially when they need it, right? So the experimental feature there is not that it's telling you that it is not ready to use. Experimental there means it might change in future. Some of the APIs might change. So if I'm using version 0.01 and it's experimental, once it gets to version 1, it's likely there's a big chance that most of the features or most of the implementation details have changed. So I have to like rewrite the code. That's what experimental there means. So you're free to use it in production. As far as I'm concerned, I use the experimental Go login collection, Go log collection on production, and it's working fine. Right. So you're free to use the experimental in production as long as you pin the dependency. That's the most important thing. As long as you pin it. So once you're using an experimental library, you have to pin the version. Make sure that it doesn't bump up, even like by 0.001. But that can change. That can break everything. So pin the version on you're good to go. With regards to collecting data from Istio and linking it with Otel, it depends on how you're collecting your Istio metrics, right? If you're collecting your Istio metrics, using like a service monitor that with Prometheus, basically, you can link that Prometheus up to Otel. And Otel will do everything for you, right? You can push the Prometheus metrics to Otel, and Otel does everything for you. But as I said, everything basically depends on how you are collecting the Istio metrics. How you're collecting the Istio metrics will determine how you're pushing that metrics to Otel. And that's how it works at the end of the day. Yeah, does that answer your two questions?
Yeah, but the thing is, I read somewhere, although I would say the person is a little bit biased because he's all in for open telemetry. So he said there are some limitations of Istio when it comes to observability, that there are some kind of infrastructure that Istio cannot give you metrics on. I should just use Otel to just instrument the application and forget about switch off the features of Istio. So that's what I'm thinking in my head.
Oh, okay. You can surely do that, right? So this conversation is derailing a little bit, but let me just chip in here. Let me just give some very like a small advice from my own end. So Istio, one advantage Istio gives you over other things is Istio allows you to not implement tracing on different applications. So for example, if you want to collect granular metrics, you can instrument a single application, right? You can instrument the application with Otel. But if I have like 1,000 services and all of these services don't have tracing, I can just deploy Istio and then put Istio in front of everything, and Istio does like most of those metrics collection for me. That's like the give and take that Istio gives you with regards as opposed to instrumenting everything with Otel. So Otel gives you that flexibility to collect the metrics themselves, but Istio gives you the flexibility of like collecting metrics from different systems at the same time, even though those metrics might be limited. You get, so depending on what your choice is or what you're looking for, you might go for one or the other. But yeah, I think that's
that. That's okay. Thanks.
All right. Who's about sharing? Yes, please.
Yeah, hi. So yeah, I mean, I've used open telemetry for I guess collecting traces. And you talked about service monitors, which gives you the flexibility of just exposing your metrics, and Prometheus can scrape it, right? Is there any how do you automatically scrape all those like your endpoints using Otel? Does it have a way to, or you have to specifically define script targets, which can be a problem if I have to start doing that for each application?
All right, so cool. With service monitors, right? Before you use a service monitor, or before you use a service monitor, you need to create a service monitor CRD. That's if you're on Kubernetes, or you have to like do manual Prometheus configuration. So OpenTelemetry now has something like a service monitor, but in like a CRD format as well. So what I mean is you can create, let's say if you're using a Helm chart, for example, alongside your service monitor, you can create an OpenTelemetry. I think it's called OpenTelemetry Service Monitor as well. There's a CRD for that. So you create it alongside your application. So you don't have to stress with having to define it along like in all your services. You don't have stress, you don't have to like bother about managing one giant configuration. Right. So if you're on Kubernetes, there's a custom resource for that as well that helps you manage the configurations for all your services without having to stress with bumping everything into one single configuration. Does that make sense?
Yeah, please share this. I guess I haven't come across.
Yeah.
I haven't seen it.
Yeah. I'm going to put the link in the slide. I'm going to add it to the end of the slide. And then yes, I think the moderator or the moderator will share. Ade Dolako. I hope I'm pronouncing that right.
Yeah, you're correct. Mmadu, thanks a lot for this. So I wanted to ask, I've worked a bit with open telemetry too, but I think one major challenge I've had is what kind of deployment, like when you're trying to centralize open telemetry deployment. So look at this kind of thing, like you have applications from different systems. Do you deploy it in every host, or do you centralize the deployment? I'm just trying to look at what kind of ideas have you or patterns have you used in the past?
All right, so that's a very, very good question. That's a very, very good question. Because now you start thinking about, should I go for like a microservice open telemetry or like a monolithic open telemetry? What I mean by microservice is you have like different collectors doing different things, right? Or do you want to have like a single giant collector that collects all your metrics? So at the end of the day, it still boils down to the resilience of your systems and what you are looking for as a company. From where I am sitting, we use a single open telemetry collector to orchestrate everything. So we have a lot of clusters, and then we use one single um, open telemetry collector to route the to like collect the metrics and then push them to like all the required exporters. But at the same time, your use cases might be unique. You might have some services that are pushing a lot and lot of metrics, right? Or a lot and lot of instruments. And you want to dedicate a single dedicated collector to that particular service. You can also deploy like a single open telemetry collector just for some of those services, and it's going to work fine. But at the end of the day, I think you have to consider the complexity of your setup and how easy it's going to be to manage. Most times, I don't know, maybe I'm not speaking from a biased perspective, but I think most times start with a single setup, and then as you hit the bottlenecks, you can then see like the need to split that single setup into like a microservice into the metric collector set. Does that make sense?
Yeah, thanks. Makes sense. Yeah.
All right. Yeah, so I don't think I'm seeing any hands up. Chris, I think I saw your hand up for a second, but I think it went down. Do you have a question?
Yeah. Thank you so much, Manasseh, for the beautiful presentation. But the question I had was already answered from Shay's question and Adidalako. But what I wanted to say was, I wanted you to talk a bit more about how using open telemetry in the Kubernetes space, sort of. From what I see, it's like a big funnel that just helps you channel, all this data into wherever you need it. But then in my head, I'm thinking I've not worked with open telemetry before, so I might be making uninformed comments here, but in my head, it looks like it's more prominent for tracing, for application metrics and all of that. But what of the granular base level Kubernetes metrics? I just want to, monitor my Kubernetes metrics, not going into the details of the application now. I know that how beautiful open telemetry is for all of that, but what of just the basic Kubernetes stuff? Does it still work that way? I don't know if you get my question. I don't even know what the question is.
Yeah,
You get the point.
I think I understand your question, right? So, when you deploy like a Prometheus when you deploy the Prometheus stack, whether it's Prometheus, Grafana, Prometheus and Grafana on your system, it comes with like default dashboards that comes with like default monitoring for your cluster. So you're wondering if you can port that to open telemetry. Am I getting it right?
Yes, sort of. Like, can it also do that as well as the other things it's doing? Like, if I just want something simple.
So, I hope I'm understanding the question right, but let me try and answer and see. And then you tell me if I managed to hit the nail on the head. So with open telemetry, as I said, everything depends on whether you're starting a new service from scratch or you are trying to move around, like you're trying to move from an existing system to another system. So when you deploy like a new cluster and you install Prometheus, you install things like kubestate metrics, you install all those Prometheus exporters, what they do for you is they collect all those metrics for you and then they push it to Prometheus. So at that point, if you want to just query the data from Prometheus, it's fine to not just open telemetry, right? Because everything is fine. You can see query the data from Grafana and then visualize the data you have, see the state of your cluster. But open telemetry becomes important when you want to move that data from Prometheus to a different backend entirely. Let's say you want to migrate from Prometheus to Splunk, right? And you want to move all the data that Prometheus was collecting previously to Splunk. That's where open telemetry now comes in play, right? So you can now install open telemetry to scrape Prometheus and then push the data to Splunk. Right? Does that answer your question?
Yes, it does. That was exactly what was in my head. Like, if I just want, like, I already know, for example, that I want to use Prometheus, and maybe for whatever reason, like I said, it's simple. I just want a simple monitoring solution. I just want to go directly. I don't have foresee, migrating that data anywhere. how does open telemetry help in that case? That was more of the question. Like, yeah, but that answers it. Thank you.
Yeah. I mean, if as a company you are so 100% sure, or let's say to a certain level sure that you are boxed into this particular vendor, there is no need of migrating your existing services to Otel. I think Otel becomes important when you're bringing up a new service and you're wondering, maybe in future we might move away from data that we might move away from this. Then you might start thinking about how to instrument those new services. But if you already have services and you already have like a platform you use for metrics and you're sure that that's what you want to use, then I don't think Otel is meant for you. I think I did not add that to the slide, but yeah. Thank you for that question. It was very, very important.
Yeah, sorry, I have one more. I'm so sorry, I'm taking so much time. The last one
No,
was,
it's fine.
this might be a bit sentimental, but now with the initial example, you know that most applications, the developers just write their logs, whatever, into varlog, and then Prometheus, whatever, can just take data from varlog and then process it and all of that. Now, would you say that instrumenting your code, like you mentioned, implementing it, would you still say that it's, I don't know if I want to say this, but would you say it's more of an infrastructure thing? Because I don't know. Would you say it's more of an infrastructure thing or something for the developers? I would say it's an infrastructure thing, but in my head, because I'm seeing, all the different languages, C#, Go, and all these beautiful things, is making me question where like, what's the line? Where does it fall? That sort of thing.
A beautiful question. So as I was explaining earlier on, there are like two facets to Otel. A new service, which is this, when I say a new service here, what I mean is a service you're writing by your own self, and an existing service which you're not writing by yourself. So for a new service, that's what the developer is writing, right? Otel, like the instrumentation language is up to them to choose. So for example, if I'm writing a new service, for example, I'm writing like a new backend, a web server, and I want to collect metrics from that web server. Normally, if I'm using Datadog, I would have to use Datadog libraries within that code and then collect metrics within that code using Datadog libraries. But if I want to make sure that I am vendor agnostic as a developer or as a company, when I'm writing a new service, I'm going to write that service and use Otel libraries. That's the developer here right now, When it becomes an infrastructure, when it becomes an infrastructure layer problem is when it is an existing service, something that you're not writing from scratch, or something that you're not maintaining. So say for example, like ingress and Nginx ingress controller, for example. You're not the maintainer of Nginx ingress controller. That means it has come with already existing instrumentation, right? By default, Nginx ingress comes with Prometheus libraries used for collecting metrics. So in this case now, if you want to use Otel, what you have control over is the metrics that are being exposed by Nginx. So that's where the infrastructure problem comes in. So you can now come in, define Otel to collect those metrics from Nginx, which has been exported by Prometheus. So basically what you're doing is Otel collect these metrics from Prometheus and then push these metrics to wherever you want to push the metrics to. But if it is a new service and you task your developers to write a particular service, then it is up to the developers to instrument those code with the Otel libraries. Does that answer your question?
Yes, it does beautifully. Thank you so much, Manasseh. Thank you.
All right. Yeah, you're welcome. Shay again.
Yeah, sorry. I guess this is a pretty strict question. Can we use it? Can we just drop and replace Prometheus? I guess one of the things you've been talking about is collect metrics.
I love that question.
I mean, you're not collecting metrics from Prometheus. I guess that's what you're trying. You're actually collecting it from the applications which are exposing it in that particular standard, which Prometheus is the de facto standard, right? So can we just use it as drop-in replacement for everything? I mean, I can get my logs, I can get my traces, I can get, what do you call it? Metrics, traces, and logs from it. Can we just use Otel as that drop-in replacement?
You can, if you are a daring and adventurous engineer. You want to do new things, right? But you have to also think about this from the management perspective, like the man hour that will be involved in doing this. So if, for example, everybody's comfortable with Prometheus, no one is even budging and saying, okay, we might not be moving away from Prometheus for a long time. You get, and there's no need to re-instrument your system, right? There's no need to try to force a new framework entirely. Drop Prometheus and use Otel. But at the same time, if you've discussed this with your team and you've decided that, okay, this is the best way to go moving forward, then you can absolutely drop Otel. So you can absolutely drop Prometheus and replace it with Otel. You can absolutely drop the Prometheus service monitors and replace it with Otel. Not because you're not dropping Prometheus completely, right? You're just dropping how the metrics get from Prometheus, the application to Prometheus.
I'm saying that we're not even installing. So you have a new system and then you don't even want to. Let's say you have a new system, you are building a new system, you know, they're integrating with, let's say, New Relic, and you just don't want to, you know, use Prometheus at all, right? Like, can Otel do all those functionality for you, right? Like, can it? So you don't need Prometheus. That's all.
That is exactly what Otel is for, man. That's the beauty of it. That is what it was meant for. That is the environment it thrives in. When you are thinking of moving across vendors, you can take out the Prometheus part, plug in Otel, put New Relic as your exporter, and watch the fireworks. Everything just goes like everything just seals. Yeah.
Yeah, because I mean, you know, when you run Kubernetes, you start installing this tool, that tool, this tool, and now that you have something that can do both, everything, it would be nice to just do it from the place. Thanks.
Yeah, exactly. Victory, your question?
Yeah, thank you so much. I really appreciate you. So let's assume you just inherited a system. You don't even know the log exporter they used on that system. And let me say they were not really using more of monitoring and tracing before, and they ask you to implement monitoring and tracing. No, the first one like being that the tools I've used before is Prometheus, Loki, and all. You implement that, and just like Empress said, all you are getting is just the normal bar logs that they've exposed, but they are telling you we need more of this tracing, we need more of this. Should you now start asking, oh, this application, I really don't understand. What log exporter are they using? What if there were no log exporter? In such a case, is there anything you can do when this application already legacy application running already on the systems?
Victory, I said easy questions. Well, yeah. That's a very, very nice. That's a very nice question, right? Observability, for a company to implement observability properly, right? There has to be a glue between the engineers, the infrastructural engineers, that's the SRE, the DevOps, and the management, right? Observability is not the duty of one person. It's not the duty of one team. That's one thing you have to understand. As an SRE, you are mostly tasked with working with the metrics that you have access to. That's the metrics that those applications expose. So, for example, if the application expose like a Prometheus endpoint, you scrape those metrics, those endpoints, and give them like a nice dashboard to see their data in. If they give you some logs, this is your duty to collect those logs. But that is it. As an SRE, your hands are really tight to when it comes to the metrics or the instruments that are within a particular system, right? So if they want more, it's now up to the developers to add more metrics, more tracing, more logging to that application. I don't know what you're coming in as it an SRE or a developer. But what I want to tell you is everybody has a role to play in observability. It is not necessarily, it is not the role of the SRE to go and instrument an application he did not write in the first place. Whoever wrote the application in the first place is the person who understands the application, understands the question he wants to ask that particular application, and understands the answers they are looking for. If I'm writing a website, let me not use the website, I'm writing a bank application, right? And I'm the person that wrote the code, so I will know what I want to see that will make me understand that this service is functioning fine. You get? So it is not something that you would just magically want to collect data from when there is no data as an SRE. The data has to come from something that has been thoughtfully added by the developer. You get my point. So yeah, you cannot just magically add data that is not there. the data has to be added first.
Hmm.
I don't know if that answers your question.
Yeah, that's my question. That's my question.
Yeah,
So when they're asking you that we want more observability, just say then we're going to meet your developers.
exactly. Exactly. That is, you see, that is like, there has to be that understanding, right? You have to make the team understand that observability is not the role of one person. It's not just SREs. We don't do magic. We don't just come up with data from nowhere. If you don't add proper login to your code, if you don't add proper metrics to your code, we cannot manufacture metrics that are not there. If we give it to you, you're not going to feel like, where are we getting this data from? Get my point? So you have to tell them that they have to add those to the code. They have to add the telemetry to the code. And you play those telemetry, you give them the dashboard they're looking for, and everybody is happy at the end of the day.
Okay, so as an experienced SRE like you now, right? You get into an organization and let me say they were not really they were just doing normal Prometheus Grafana, and they say, oh, we now want to implement Datadog for proper observability, right? And they
Yes.
say, okay, implement this Datadog, we want this, we want that. The truth is that the log that the Loki or Prompter is scraping before, it's still the same log Datadog is going to scrape when you implement an agent of Datadog. But they are believing that because they are now moving to Datadog, they want more metrics and all. So how will you now tell them that no, you are not going to get more metrics except this application really exposes? No, I'm just saying, except this application really exposes this and this. What you are getting before you see what you are going to get. It's not about how fine the tool is now that you are moving to, but about the code. Because it's like, I don't know, there's actually this disconnection. Or is there anything you can now do with the Datadog to make it more finer compared to what Loki and Prompter is doing? Or Open Telemetry can make it more beautiful?
I love this question, Victor, because this is always a problem, right? This is a process. This is always a process problem most times. So, as Adedolapo has said, you have to educate the team. So, one thing most times I like to do is let's run a spike, right? You don't just jump into implementation. Let's run a spike. What is the outcome of this spike? The outcome of this spike is to analyze the application we have and what we need to add to get proper metrics on Datadog. So once you've done the spike, analyze the application, analyze the log that this application produces, you test this application on Datadog and see what Datadog gives you, and then you document the outcome. You tell them this is what we can get when we use this application as it is on Datadog, right? Document it, management log documents. Give them a very nice document. Tell them this is what Datadog is going to give us. But if we want more than this, if we want proper tracing, then we have to do the due diligence of adding tracing to this application. Then you cannot propose, okay, let's use Otel, right? Let's use Otel to instrument this code because we might choose to switch to something else in future. So you tell them, all right, we have to instrument this code with Otel. You have to also break down what tracing is because, as you've earlier said, they don't really like some of the higher ops. They don't really understand the lower operations. You have to tell them, okay, this application right now doesn't have tracing implemented, and in their head they're like, tracing. What is tracing? I thought tracing came with Datadog automatically. So you have to explain it. You have to, as I said, write a very, very nice document explaining everything, explaining tracing, explaining why it is important, and explaining how this application right now doesn't have tracing implemented. When you've done that, then I think, yeah, you can give that as a proposal. Once it's done, you create your epic, assign the tickets to the developers, add the tracing, because everything has to be documented as the outcome of this particular spike. I'm speaking from how the process, how I do things from where I am, right? So once you've done this, you give them this for review, and the ones they read it, they are able to understand where you are coming from as a developer. They're able to understand the limitations of their current system and the limitations of the system they want to move to. They can even have tracing on Grafana if they want to as well. You can even add all those details that will make them understand all this is properly. And then you create a build, you pass, and then you hope that they take you up.
Thank you so much. I appreciate it.
Yeah. So yeah, I think that's the end to the questions.